All right, guys, multiplication properties of exponents. Let's do this. I told you in class there's going to be 3 main properties that we go over today, so you're going to want to take very, very good notes or else this is going to get really confusing. Here's our first one. It's called the product of powers property. Now I want you to maybe put your pencil down, just listen to me explain all this. You can press pause, rewind, go back, and write it all down. And maybe listen to me say it again. I want you to do that for each of the 3 properties, or else these are going to all just run together and you're going to be so confused at the end of this video. Okay, so let's just listen first. First of all, we're going to take a product of powers, okay? So I have 3 to the 5th and I have 3 squared, and I'm going to figure out what I get when I multiply those together. So what we know is that 3 to the 5th is 3 times 3 times 3 times 3 times 3, 5 times, right? I know that 3 squared is 3 times 3. Okay, so I've written that out long. I've expanded it, okay? And now I'm going to multiply those together. So I have 3 times 3 times 3 times 3 times 3 times 3 times 3. How many of those 3's do I have? Well, I have 7 of them. I had 5 from this term and 2 from that. So 5 plus 2, I have 7. Okay? So product of powers property, the product of 2 powers with the same base equals that base raised to the sum of the exponents. I want you to write that down. The key here is that the base has to be the same. So let's look at this example. 6 to the 7th times 6 to the 4th. The base is 6. So I have 7 6's from this one, and then I have 4 6's here. Together, that makes 11 of them. So 6 to the 11th would be my answer. Okay, let's do some practice problems once you've copied all this down. Here we go. 3 squared times 3 to the 5th. 3 squared is 3 times 3. 3 to the 5th, 3 5 times. What do? I have 1, 2, 3, 4, 5, 6, 7 of those. So I have 3 to the 7th. Well, how did we get that? This is the same thing as 3, and then I add their exponents together, 3 to the 7th. All right, let's look over here at this example with q's and r's. I have q to the 3rd, which is q times q times q. R squared is r times r. Q to the 6th is q 6 times. Okay, so I can write this out as long as they don't give me like q to the 100. Okay, but while the numbers are small enough, until we get the hang of it, we can write it out long like this. Now I'm going to combine everything that I can combine. Well, I have 3 q's here and 6 q's. That makes a total of how many? 9 q's. The r's can't be combined with q's, so I just write their total right next to it. This is the same thing, though, as r squared q to the 9th, right? Just like 2 times 3 is the same thing as 3 times 2. Doesn't matter which one we write first. Okay? Now I'm going to show you how I got this. I took q, my first base, and I added the exponents, 3 plus 6, to get q to the 9th. I didn't have to do that with the r's because the r's were, that was the only r term that we had. Now let's look at the example down here with the 2's and the 3's. I have 2 to the 4th, so 2, 2, 2, 2. All those are being multiplied. 3 to the 4th, that's 3 4 times. 2 to the negative 2nd, so that would be like 1 over 2 squared. So 1 over 2 and then 1 over 2. And then I have 3 squared, so that's times 3 times 3. Now I'm going to combine all of what I have. So let's figure out how many 2's. I have 4 2's, but then I have these 2 2's that are on the bottom. So those are going to cancel with 2 of those. So how many 2's did I really have? 2. How many 3's do I have? 1, 2, 3, 4, 5, 6. So times 3 to the 6th. Now how could we get that answer? Okay, I'm going to erase all of this, and I'm going to show you how we could get that answer without writing it all out that really long way. I'm going to take my base of 2, which are right there and right there, and I'm going to add their exponents. 4 plus negative 2. Then I'm going to take the base of 3, and I'm going to add those exponents, 4 and 2. So what do I end up with? 2 to the 4 plus negative 2 is squared, times 3 to the, what's 4 plus 2? 6. Okay? You can leave your answer like that for now because I don't want to do 3 times 3 times 3 times 3 times 3 times 2 times 2. Okay, we could do that, and we could simplify and get one number, but for now, we're just going to leave it like that. Let's go over here. I have all n's. So I'm going to keep my base of n, and I'm going to add all their exponents. 3, negative 4, and what's this exponent right here? It's a 1. So I'm going to write n, keep my base just one time, plus negative 4 plus 1. Let's see, what do we get? N to the 3 plus negative 4 is negative 1, plus 1 is 0. What is n to the 0? 1. So our answer to that problem is 1. All right, let's go to the next property that we have, and this is the power of a power property. So it's when we have a power, something like 4 to the third, and we raise that power to a power. 4 thirds squared. What does that mean? This means that I'm going to square what's in parentheses. Well, what's in parentheses? 4 to the third. So I have 4 to the third 2 times. 4 to the third times 4 to the third. I like to think of this number right here, this exponent, as like how many copies am I making of what's in parentheses? I'm making 2 copies of 4 to the third. So I have 4 to the third, 4 to the third. Well, what is 4 to the third? It's 4, 4, 4. 4 times 4 times 4. Times 4 times 4 times 4. How many of those do I have in total? I have 6. Okay, now surely there has to be a pattern to that. Okay, if you notice that the exponents, okay, in the original power, which was a 3, and the exponent in the final power, which was a 2, if I multiply those powers together, 3 times 2, I get my ending power, which is a 6. The ending exponent is a 6. Okay, so here's the rule. A power raised to another power equals that base raised to the product of the exponents. So I have 6 to the 7th to the 4th. So I'm making 4 copies of 6 to the 7th. So 6 to the 7th, 6 to the 7th, 6 to the 7th, 6 to the 7th. Well, think about that. 6 to the 7th is 6 7 times. So I've got 6 7 times from here, 6 7 times from here, 6 7 times from here, 6 7 times from here. How many total 6s are that? 7, 7, 7, 7. 7 times 4, 28. So my total answer was 6 raised to the 28th. Again, how did we get that? Very short and easy. We multiplied those 2 exponents together, the 7 and the 4, to get 28. Okay, let's work some examples here. I have 5 squared to the 4th power. So I have 5 squared 4 times. Okay, 5 squared, that's 5 times 5. Then I have 5 times 5, 5 times 5, 5 times 5. How many 5s in total do I have? 8. How can I get that? I take 5, my base of 5, and I multiply the exponents together. Multiply those 2 exponents together. So let's apply that in B. I have 4 to the third to the 0. Multiply the exponents. 3 times 0 is 0. What is 4 to the 0? 1. Let's look at the next one. Here I have x to the third raised to the negative 5th. So first thing I'm going to do is I'm going to multiply my exponents together. I'm going to get x to the negative 15th times x to the 4th. Okay, now this goes back to the first property that we learned. The first property, product of powers. What was the rule that I use when I have a product of powers? I keep my base of x and I do what to their exponents? I add them. So I add the negative 15 and the 4 and I get x to the negative 11th. Can we leave our answer as that? No, we can't. We can't have negative exponents. So my final answer is 1 over x to the positive 11. How did I know to add my exponents here instead of multiply them? Because I have a base of x and a base of x. This is the easiest way for me to explain it to you. When your base is being written out multiple times, okay, an x there and an x there, we're going to add the exponents, okay? But when a base is only written once and you have 2 exponents that follow it, you're going to multiply. So go back and stop right now before we learn that third property And make sure you know the difference in your head between when do I have a product of powers and when do I have a power of powers. When do I multiply the exponents and when do I add the exponents? That's a really, really important thing to get before we move on. Let's do this last example. I see one base of 3 and I see 2 exponents that follow it. So I'm going to multiply those together. Okay, see how I'm showing my work here? I'm showing how I'm getting this answer of 3 to the 20th. It came from multiplying 4 times 5. All right, so take a break, stop, pause, wrap your head around all that. Once you've done that, let's look at this third property. Here we have a power of a product, okay? An example, 8x being cubed. So I have 8x 3 times. 8x times 8x times 8x. If I break that down, it's like having 3 8s and 3 x's. So I get 8 cubed, x cubed. 8 cubed, 8 times 8 times 8 is 512 x cubed. Here's another example, 2 times 4 being cubed. I have to do the 2 cubed as well as the 4 cubed. They're in parentheses, which means they both get cubed. Okay? Let's look at some examples. Negative 5t squared, all of that's being squared. So I have negative 5t squared, but I have 2 of them because it told me to square what was in parentheses. So I wrote it out long ways. Now, let's see what we get. I'm just multiplying, right? So I'm multiplying negative 5 times t squared times negative 5 times t squared. So let's multiply this stuff. Negative 5 times negative 5 is 25, and t squared times t squared. Okay, here's one of our rules, our very first rule. I have a base of t, and I have an exponent of 2 and an exponent of 2. My base is written out multiple times. So do we add the exponents or do we multiply them? We add them. So 2 plus 2 gives me 4. So there would be my answer. Okay, another way of thinking this is this squared applies to the negative 5 and the squared applies to the t squared. So I'm squaring negative 5, which gave me the 25, and I'm squaring t squared. T squared times t squared is t to the 4th. Let's look at this example, negative 2y to the 3rd power. So I have 3 of whatever was in parentheses. What's in parentheses? The negative 2y. Now, remember, I can write this as, I don't know what is going to work best for you, for your brain to see this. You could write all your negative 2's together. I had 3 of them. And then all your y's together. And now let's multiply. Negative 2 times negative 2 is 4. 4 times negative 2 is negative 8. What's y times y times y? That's y to the 3rd. Remember, these all have exponents of 1. So when I see my base being written out multiple times, what do I do to the exponents? I add them. Okay, so that's all of the rules coming together. So there's my answer, negative 8 y to the 3rd. Okay, we're just going to do one of these, all right? We're going to do the top one. X squared y to the 3rd to the 4th. So I have 4 of those. Instead of writing that out, I'm going to apply the 4 to the first term and the second. So I have x squared to the 4th power. I have y to the 3rd to the 4th power. Okay, let's see what we get there. I only have the base x written out one time. Then I have 2 exponents that follow. So that's going to be x to the 2 times 4, y to the 3 times 4. That's x to the 8th, y to the 12th. Now let's worry about all this stuff. I'm going to give my negative 4 exponent to each. So I have x squared to the negative 4th, and I have y to the 4th to the negative 4th. So what do I get? X to the negative 8th, y to the negative 16th. So I'm taking, if I write all this together, I'm taking this stuff and multiplying them together. So x to the 8th, y to the 12th, times x to the negative 8th, y to the negative 16th. Keep in mind this is multiplication, so I can write them together in any order that's going to be easiest for my eyes to see. X to the 8th and x to the negative 8th. I see my base of x, so I'm going to write it one time, and I'm going to add their exponents together. 8 plus negative 8 is 0. Now I see my base of y, so I'm going to write y, and I'm going to add those together. 12 and negative 16, and I get negative 4. Okay, now I'm going to simplify this. We know we can't leave our answer with 0 exponents or negative exponents. X to the 0 is 1. Y to the negative 4th has to be rewritten with the 4 in the denominator of the fraction. So y to the positive 4th, that's our answer. I think that's enough to leave you with. We'll do lots of practice problems in class. Have a great night.